is EDM? EDM is electrical discharge machining, also known as spark machining, spark welding, die sinking, wire burning, or wire erection. Is a metal fabrication process whereby a desired shape is obtained by using electrical discharge. Material is removed from the workpiece by a series of rapidly recurring current discharge between two electrodes separated by a dielectric liquid and subject to an electric voltage. An electrical discharge machine, when the voltage between the two electrodes is increased, the intensity of the electric field in the volume between the electrodes becomes greater. Cause dielectric breakdown of the liquid and produce an electric arc. As a result, material is removed from the electrodes. Principle of operation. First, both workpiece and tool are submerged into dielectric fluid. The dielectric fluid helps to control the arc discharge. This also removes suspended particles of workpiece, material and tool from the work cavity. Secondly, a servo mechanism is used which maintains a very small gap between the workpiece and the tool. This gap is desirable for proper arc formation. It is about the thickness of human hair. Number 3, the tool is made as the opposite shape of workpiece. Number 4, a high frequency current supply to electrode which produce a spark between the tool and workpiece. This spark generates heat in work cavity. Number 5, the metal removed from the workpiece due to erosion and evaporate iron. Number 6, the chips or suspended particle between tool and workpiece should be removed to prevent them to form breach that cause short circuit. This is done by continuous supply of dielectric fluid. And lastly, the ADM produces a cavity slightly larger than the electrode because of overcut.
Machine parts and components. First, pulse generator power supply. The power supply is given to the EDM process. Negative terminal is given to the tool and a positive terminal is given to the workpiece. Second, workpiece. The workpiece is fixed in the dielectric container using a fixture and is given the positive terminal of the power supply. Third, fixture. The fixture is used to hold the workpiece properly in a dielectric container. Fourth, dielectric fluid. The workpiece and the tool are separate using dielectric fluid and an optimum gap is maintained between them. At normal condition, dielectric fluid acts as an insulator. In this sense, no electrical conductivity is taking place. See pump. A pump is used to send the dielectric fluid from the base of the container to the tool and workpiece, such as the more MRR take place. 7. Filter. A filter was situated just above the pump to remove any irregularities or dust particles present in the dielectric medium. Next, tool holder. It is used to hold the tool properly. Next, spark generation. A spark is generated between the tool and workpiece in the presence of dielectric medium, and thereby material removal take place from the surface of workpiece. Lastly, tool. The tool used in the electric discharge machining process is either copper or tungsten or copper tungsten alloy. Application of the machining process. It is mostly used by mold making and die industry. It is used in a prototype manufacturing in aerospace, automobile and electronic industry. It is used for furnish die making. It is used to create small holes in a variety of applications. It is used to disintegrate parts which cannot be disintegrated easily, such as broken tool, stud, bowl, drill bit, and stats from the workpiece.
Advantage: it can be used to machine any material that is electrical conductive. It can easily machine the fragile sections such as webs or fins without deforming the parts. Complex die section and molds are produced accurately, faster, and at lower price. It is burr-free process. It does not involve contact between the tool and workpiece, so delicate section and work material can be machined easily without any distortion. It can machine complex shape which is not manufactured by the conventional machine tools. It can produce tapered holes.
Disadvantage: it can machine only electrical conductive material. Low rate of metal removal, more tool wear during machining, takes extra cost and time for the preparing electrodes from ramp or single EDM. High power consumption, overcut is formed in EDM.
Thank you.